Ladies and gentlemen, men and women, boys and girls of all ages, welcome to Church Hurdles, Episode 3. It's not the thriller in Manila, it's not the Revenge of the Sith or the Search for Spock. It's the Cosmological argument. In the right corner, standing approximately 6'2" and weighing not much more than a large lapdog. You know him for his long-winded explanations, and as that one guy who has all of those kids. It's Matt Hodge! And in the corner with him, standing at a best guess 5'4" and weighing in at a stunning, I'm not going to go there because I like my job. The embodiment of curiosity and the holder of the rights to this show. Number 2 on your screen, but number 1 in your hearts because she told me to say that. Susie Matthews! And now, let's get ready to hurdle!
Well,
that's the best.
That I feel like we should start paying him.
No kidding.
I'm
that
just
was
throwing
the
it
best.
out there. Yeah, that was really good.
Yeah.
And he got my height right on the number, and I'm glad he didn't get my weight anywhere near close. So very good. Awesome job, Craig. That's awesome. So
Susie, do our intro about welcoming everybody and telling them asking them to ask questions. I guess we're not going to tell them to do anything.
Yeah.
And all that good stuff that I'm going to forget.
Things. Yeah, I tell everybody to do things they're used to that. So for those of you who haven't joined us in the past, and for some of you that know me, basically Church Hurdles is literally everything that is a hurdle for either your belief or faith or attendance of a church or just hanging out with cool Christian people. And sometimes, I think there's a lot of religion involved in some of the stuff that is a huge turnoff for people. I know it was for myself. And sometimes it takes a long time to find somebody who can answer questions. And I don't mean like just the basic stuff. I'm just talking somebody who still wants to be cool and chill and hang out with you, like my friend Matt here. And so we are exploring all the various hurdles that people have. I've kind of designated them for myself as the first hurdle being do you believe in God? And if you believe in God, if you get over that hurdle, then do you believe that Jesus ever existed? And if you get over that hurdle, then do you believe he was God's son? So on and so forth. So we're just kind of taking these a hurdle at a time. We would really, really love to have questions or comments. We are happy to make you a celebrity by putting stuff that's appropriate up on the screen. And we really look forward to some insight. And I want everybody to know the point of this podcast is not to proselytize, evangelize, or convert anybody. The idea here is for us to all have a little bit more open mind about everything, so that we can help. Matt has been really wonderful and really wanting to understand better what is a hurdle for folks. And I was a terrific hurdler apparently. So that's how this all came to be. So Matt's kind of the little bit more of the brains, and I'm the skeptic, I guess, in all of it. So sorry I gave you that brain title there. He's the wizard.
Where's my hat?
I'll make you one.
So this week that's even more scary. So this week we're going to talk about is God real? Does God really exist? And the cosmological argument, which is our first slide there, is something. It's something that I have really had to stretch a little bit. There's part of this that's pretty simple, and yet there's part of it that's pretty in depth, and somehow we have to bridge the middle on this stuff. So first of all, as we talk about the cosmological argument, the whole point is, where did the universe come from? How did it come into exist? The cosmos, where did it come from? So
I think there's some people out there Matt, just to be clear, I think there's some people out there
Go
that think
ahead.
that the universe revolves around them. I'm not naming names.
Hey, what are you saying? What are you
No,
saying right
not
now?
you. Yeah, sorry. As a middle-aged woman, I have to have my fan. So
Ah, we like fans at my house a lot too, so
yeah,
it's all good. All right, so um, Lee Strobel, the author of our book that we're kind of showcasing, the case for a creator, he says, my road to atheism was paved by science. And that's what we would expect, right? He says, but ironically, so was my later journey to God. So, we're not here just to say, well, God exists because the Bible says so. As a matter of fact,
right.
there's just a ton of science that we actually want to go through. So, we're going to examine a little bit about the Big Bang. That's kind of what the cosmological argument all rests on. And we're not really discussing in this show, were there billions of years? What's the age of the Earth? We're just
Right.
taking the Big Bang at face value and looking at it. So this is kind of a picture of the typical Big Bang, right? There was initially just some very basic elements. Maybe there was just a quantum energy field. There was a little bit of nothing, and suddenly it exploded, and more particles formed, more types of particles formed. You had chemical evolution occurring. Eventually, some stars can begin to form, and then they began to cook the heavier elements inside the stars. And they then get radiated out of the stars into the cosmos, where they can then be reassimilated into other stars and recooked. And then you have the heavier metallic elements being formed. And eventually, after billions and billions and more billions of years, you get it takes a while for a universe to
Yeah.
form.
I know. Have you ever made cookies? They take a while too. I mean,
Wow.
maybe not as many years.
That's probably why I'm so skinny. I had to wait that long for cookies.
Oh my gosh. I obviously found them
pretty
before you
awful.
did.
Well, you'd be a better I can't find a way to say that. You'd be a better universe than I would. Anyway. So sorry. So we have this universe here now, and we kind of laid down the beginning point, right? I want to read just a few quotes here. It says Nobel Prize winning physicist Steven Weinberg, in his book The First 3 Minutes, says this would not be an explosion like those we're familiar with on Earth, starting from a definite center and spreading out to engulf more and more of the circumambient air. That's what he said. That's not what I said.
Wow, that sounds
And
yeah.
circumambient air. I had to look at that 3 times before I read it.
Yeah. I don't know.
But
Maybe
this
a
would be
reference to Taco Bell or something.
It could be. But this is an explosion that began, and let me read this verbatim here. It was an explosion which occurred simultaneously everywhere, filling all space from the beginning, with every particle of matter rushing from every other particle. So he's trying to paint a picture in our minds of an absolute nothingness. And
right, which is really hard for us to wrap our heads around, because
these particles wouldn't be like all the ones we know of today. Again, they would just be your lighter gases. All right, let's see here. He goes on to say, within the tiniest split second, the temperature hit 100,000 million degrees centigrade. This is much hotter than the center of even the hottest star, so hot, in fact, that none of the components of ordinary matter, molecules, or atoms, or even the nuclei of atoms could have held together. So
but it's definitely hotter than the oven to make cookies.
Right.
So
right. Also, fewer ingredients went into it originally.
Right. Probably less tasty, just throwing it out there.
For sure. So this is the part that's kind of mind-blowing to me. He says the elements would have been negatively charged electrons, positively charged positrons and neutrinos, which lack both electrical charge and mass. Interestingly, there were also photons. The universe, he said, was filled with light. So the most intriguing question is, what caused the universe to spring into existence? Right? What was the match that lit the fuse? What was the trigger that was pulled?
Mm.
So that brings us to our deal today. Let's see here. I've got another quote. Who is this from? This is from Bill Bryson in A Short History of Nearly Everything. He says, that's what he says.
All right.
He vaguely speculates on exotic theories about a false vacuum or a scalar field or vacuum energy. Now, just think about that for a minute. That's a vacuum, so there's nothing, and there's energy in it. That seems to be a self-contradicting term, but maybe there's something I don't know. Some sort of quality or thing that may have induced a measure of instability into the nothingness that was. So it's all a little hard to fathom. It's a little hard because if there's nothing, how can it be unstable?
Well, I don't have that answer.
When there's nothing in my gas tank in my car, it's not unstable. It's very, very stable, and I go nowhere.
It's very stable. It's very stable at a stopped standstill. Yes,
exactly.
Yeah. I like to play that game. I like to play the game to be like, I know it says I'm out of gas, but how really out of gas am I? So Emily, on the other hand, has actually succeeded in finding that to its conclusion. I'm not that brave. So one of the things I think, first of all, it's hard for us to imagine nothing, or a literal nothing.
Really is,
which is, because I mean, we have to live within the confines of our minds, and if you're living within mine, that is extra special. So if you don't have anything, and I think that's the hardest thing for people, and then people would say, of course, well, if there was nothing, then let's say there's a God. Well, then who made God? And
okay,
so
you're way ahead. We're going to get to that later, but yeah.
Okay, well, sorry about it, but I think that the first thing people have to remember is there was literally nothing. I mean, the blackest of black and the darkest of dark and the emptiest of whatever. I mean, all we know is, of course, everything that we see around us every day. So we can't imagine just nothing.
They talked about that in the book, and they talked about how, like, it's really hard to imagine nothingness to the degree that we're talking about.
Right.
If there was a Big Bang, there was a beginning point. Well, let's jump into the kalam argument. That's where we're going to spend probably most of our time this evening. The cosmological kalam argument. And it goes like this. Whatever begins to exist has a cause. That's the first tenet of the theory. The universe began to exist. And of course, each of these we're going to need to substantiate. We're going to need to prove them. Mm-hmm. But if those first two things are true, then the natural conclusion is the universe has a cause. Whatever begins to exist has a cause. The universe did begin to exist. Therefore, the universe has a cause.
Right.
All right. So, pretty simple. If we can substantiate the first two, the third one should be true. So let's see what we have here. So, this is one illustration of a quantum field.
Dude, is that a wormhole?
There's a lot of stuff in there. I'm going to let you kind of
I don't know what they
figure out what's in there.
Okay.
We see these two fields interacting with each other, right?
Yeah.
They're coming together in a point. And you see the dashed lines. And so there's interaction between them where sometimes a negative will go from one side to the other. Sometimes a positive will go from one side to the other. So that's kind of the idea of this quantum energy field. So let me see here. Catch up with my notes here. Catch up with the book. All right. Yep. Okay. I'm gonna read this part. William Lane Craig is really the one who is the most knowledgeable about this. He says, when I first began to defend the kalam argument, I anticipated that its first premise, whatever begins to exist has a cause, would be accepted by virtually everyone.
Oh, cute.
One would think.
One would think.
But he said, the scientific evidence has accumulated to the extent that atheists are finding it difficult to deny that the universe had a beginning. So they've been forced to attack the first premise instead. And that was the second premise, that the universe began to exist. He says scientific evidence has accumulated to the point where that second premise, that the universe, in fact, had a definite beginning point, is pretty much a given in the scientific community. But we'll get to that next. So, then they turn around and attack the first premise. Okay.
You can't have all those premises. You got to have some fighting or it's no fun.
Of course. He says, in the first place, this first premise is intuitively obvious.
Oh, is it? Okay.
Look at my slideshow here. Okay. I think what I've done is I've skipped ahead. So we're going to go back to the previous slide. There we go. Sneak preview. All right.
We've leaked some data. Sorry, guys.
We have. Okay. So he says, in the first place, this first premise is intuitively obvious once you clearly grasp the concept of absolute nothingness. The idea that things can come into being uncaused out of nothing is worse than magic. At least when a magician pulls a rabbit out of a hat, there's a magician in the hat. So at least there's something to begin with.
Right.
With this, we have complicated, advanced forms of heavy matter, light, radio frequencies, energy, microwaves, and suddenly, poof, they're there. It's just nonsensical to say that if something began to exist, that there was no cause. This defies everything science has ever discovered. Cause and effect is like the basis of science. So, what would you say about that? Does that make sense to you, Susie, or is that intuitive, or is that evidential? Is that something that's like, okay, well, it might not be true. I don't know.
I think a lot of that, of course, unless you understand like the laws of thermodynamics and some other things, it probably is over a lot of people's heads. But we can all relate to it in this regard. If there was, so if we let's say we agree that there was a Big Bang, and so if there's a Big Bang. Again, let's and I'm going to oversimplify this for a second, but even let's just say there's this giant explosion, not really one. I'm just going to say I wasn't there, so I can't tell you. I definitely know I didn't cause the explosion. I feel fairly confident in that. So the thing is that it still came to be that we have planets and stars and matter and everything that we have, regardless, right? Even if you can't wrap your head around all of those things, you can, in fact, know, right, that we do have those things. Those things do exist. We know that there's a sun, there's a moon, there's stars. There's an International Space Station, probably not a product of the Big Bang, but still pretty cool. And so you've got that, but then at even without any kind of before I even had any real inkling to do something like this, that was never really something that I could fully buy into, that somehow just one day or whatever it was, maybe it wasn't a day, maybe this happened over the course of a very, very long time. Although they say, you've got to take the start or the point we're at now. If we work backwards, it comes to a finite stop, so that there was a point when it all occurred. And if you look at it from that vantage point, I mean, regardless of your belief system, something obviously happened. It didn't just, I mean, you can look at it 1,000 different ways, but all the things had to come together the way that they came together, exactly how they came together. And when it happened, it produced something that gave us everything that we see, or in stuff that we
Yeah.
can't even see yet. So,
Right.
that's the thing to remember. The universe is huge. We always think about our little solar system here, but we're just a small speck in it. And you have to remember that even if you don't understand all of the science behind it, common sense tells you that you know something happened. And if you want to go with for me, if you want to say that was an intelligent designer working that out, great. If you're not there yet, fine. But obviously, pretty amazing accident. I have never seen an accidental explosion yet that was like, wow, isn't it cool? I mean, I suppose I shouldn't say that. A volcano erupts and sometimes it makes an island, but it's
Still not an accident.
it's not an
Even that
accident,
has a
right?
cause. It's
Right,
part of
sure.
the tectonic plate movement and all that.
It certainly is. And that all came to exist, right? When all these certain things all got together somehow in the correct order, in the correct way, and produced what they've produced. So, um, so I don't want folks that are like, oh, you have to understand a bunch of science. You don't have to understand the science of it. I think we're just wanting to make sure that you can understand that there are some scientific theories out there that aren't based in science, but that also support the idea that there was some kind of creator or some kind of designer. Something caused it to happen the way that it did with the outcome that it got.
Right. I love how he illustrates it. Speaking of being non-scientific, he says nobody worries while they're away at work that the carpet may spontaneously generate a horse that they'll find pooping on their carpet when they get home.
Oh,
That's just not. That's not something we worry
I
about.
have actually never thought to worry about that, but thank you for a new thing. And if for those of you who have not seen the Roomba, who is programmed to sweep every day at like 2 a.m, but accidentally ran over some doggy doodles and then just tracked it all over the house in great patterns and designs, that is an extremely fun story to read. So, while we're on the topic, that would have
Like,
also had a cause and effect, by the way. So,
you have to have the dog first.
gotta
Yeah.
have the
Wow.
dog. Yeah.
All right. So, one wrinkle that we might throw in this is to say, well, see, within quantum physics, things happen that cannot be explained by the normal laws of science, and so you have particles that just kind of pop into existence and then fade back out of existence. So maybe that's where our universe came from. It was a quantum field, and it just popped into existence.
Yeah.
And of course, that's where I should have popped up the next slide. So,
Oh, it's like deja vu.
quantum theory holds that a vacuum is subject to quantum uncertainties. This means that things can materialize out of the vacuum, although they tend to vanish back into it quickly. Theoretically, anything, a dog, a house, a planet, can pop into existence by means of this quantum quirk, which physicists call a vacuum fluctuation. Wow, sounds
Wow.
like magic. So
A little
let's
bit.
get
Yeah.
to the answer here. It says Bill Craig was listening intently. Okay, that's a good question. He replied, "These subatomic particles the article talks about are called virtual particles. They're theoretical entities, and it's not even clear that they actually exist, as opposed to being merely theoretical constructs." So there's the first problem. We don't even know that these are not just appearances. He said, but a much more important point is that if we have that quantum vacuum, we've really just pushed the question of the origin back one level. Where did the vacuum come from? Where did this quantum field of energy that's fluctuating, like, where did it come from? So we still have this origination problem.
Right. And I
He
think
says,
too,
yeah,
when you say that, that's and And although we can get some great theories and stuff about it, we may never understand it, right? But it's always great to be able to think outside of our box,
That's definitely outside the box.
whichever box you're in. Yeah, I mean, if you're into the wormhole box, if you ever saw Quantum Leap, this is it for you. Because Scott Bakula, thank you for those great shows.
Sure. Well, the thing is, this is not like so mystic as they make it sound. There are laws that determine, how these quantum vacuums work. But also, Craig makes this important point. If quantum physical laws operate within the domain described by quantum physics, you cannot legitimately use quantum physics to explain the origin of the domain itself. And so if there was a beginning point to this quantum vacuum, it cannot have created itself. It doesn't work. That's one of the laws. It doesn't work that way. So, all right. So that's quantum physics there. So that really kind of clears up that first point. Whatever begins to exist has a cause. I heard a breath. What you got, Susie?
Oh, nothing. I was making faces at you while you were turned away.
So whatever begins to exist has a cause. The next point is the universe did in fact have a beginning. And William Craig says there are two ways to arrive at this conclusion. One is the mathematical pathway. Mathematical / what does he call it? Mathematical / philosophical, I believe is what he said. So he says,
and for
the universe yeah, go ahead.
Just one thing I was going to say, and for those who aren't familiar with this, like most of us, would be this was something that really wasn't kind of put into thought or put into the universe. Oh, do you see what I did there? I said universe. Until like the 70s, I think, right? This was.
Well, actually, let me kind of back up. The word kalam, if that sounds Arabic to you, it's because it is.
It is, yes. Uh-huh.
And so I kind of skipped over that part, but it has
the reason I was asking was the gentleman, though, that the guy who really gave this some real foothold, that where people were starting to really discuss it. This, I believe, was not all that long ago, was my point.
Okay.
I mean, Kalam, the argument has been there for a very long time, but it really getting now that there was science available that had been explored, it really started to take off. I thought it was like in the 70s. That was my understanding.
There was a book, 1957, that Craig kind of played off of and developed this further. So
gotcha.
Now I'm on board. I'm on board with you.
Okay, sorry.
So the conclusion that these early apologists came to was that the universe's age must be finite, that it could not have been infinite. In other words, the universe had to have had a beginning.
Yeah.
And so the reason is that infinity infinity really doesn't work in a practical setting. So Craig uses this illustration. He says, let's say I had an infinite number of marbles and I want to give you some. Well, I could do that several ways. Let's say I have this whole infinite pile of marbles. I could give them all to you. I just slide the whole pile over to you. Now, how many do I have?
Well, my math is
I would have 0. And so that's actually what's on the slide. Infinity minus infinity would then equal 0, right? But let's say I want to do something different. let's say that I want to give you all of the odd numbered marbles, and I'm going to keep the even numbered marbles for myself.
Okay.
If there are infinity marbles, then how many odd numbered marbles are there?
Infinity.
Infinity. So I give you the odd numbered marbles. Now, how many marbles do you have?
Infinity.
But I have the evens. I still also have infinity
Infinity.
marbles.
Right.
So I have infinity marbles. I give you infinity marbles, and yet I still have infinity left. In that case, infinity minus infinity equals I still have infinity left. And so this is contradictory.
Yeah.
And so if
I'm
going to give you all the marbles numbered 4 and above, and I'm going to keep 3 marbles for myself, that's it. Well, it looks like I did the slide wrong. Infinity minus 3 is what that should say. All that work, and then you come along and wow, there's still something wrong.
Buddy.
Oh well. Hey, looks like I'm not perfect. What do you know? So infinity minus 3 then is still infinity. So what it means is you cannot use infinity to calculate the age of something. So let's go on, talk a little bit more about infinity. It's pretty cool. Let's see here. Oh, yeah. We're going to talk about the impossibility of forming an actually infinite collection of things by adding one member after another. Because theoretically, it's possible, right? You have those dominoes there, or
yeah, but I'm the jerk that would push the first one.
No, I know, and then they would keep falling down forever because it's an infinite line.
Yeah, that would be awesome.
Dominoes.
Yeah.
So the problem is, though.
That makes sense. Yeah, it can't be infinite because it was finite for a moment, and then it was added, and it's and then it's finite, and then it's finite.
So if you push down the first one, and then the next one gets pushed down, and the next one pushed down, then that's really a bad example. Let me read what's in the book because it's much better. I can't figure out how to say. I told you this is kind of hard to explain. Okay, so he says, even if you could have an actual infinite number of things, you couldn't form such a collection by adding one member after another. That's because no matter how many you add, you could always add one more before you get to infinity. So you could always set up one more domino at the end. So at what point would you have reached infinity?
Well, you don't reach
infinity. You can never reach infinity. Right? So let's say we can, if our Earth has always been here, if the cosmos has always been here, then there would be past events that we could track. We could go back in the evolutionary time scale. We could go back in historical time scale, whatever, and we could see a previous event and then another event previous to that, another event previous to that. You would never get to the beginning because you can't. That's the idea of, and so it's actually impossible. Logically, it's not possible to have an infinitely old Earth. You just can't do it. Let me see here. He says the idea of an actual infinity is just conceptual. It exists only in our minds. Working with within certain rules, mathematicians can deal with infinite quantities and infinite numbers in the conceptual realm. However, and here's the point, it's not descriptive of what can happen in the real world.
Right.
All right, let's see here. He says, because of what we covered earlier, mathematicians are forbidden from doing subtraction and division in transfinite arithmetic, so anything involving an infinite number, because this would lead to contradictions. All right, so when we deal with the infinite, you can say, well, the Earth could have an infinite past, and we can have that thought, we can have that idea, but when you actually do the math, we can't. You can't get back that far. It doesn't work.
I think that it's even so, even if you could try to put some kind of box around all of those things, one of the things again that's going to come up is they still had to all assimilate themselves like they have. It's not like the earth just magically sprung into its perfect spot right now, just, I mean, on a whim. It's like, I want to be third in line. That's not what happened. So
Right.
there's so many layers to that. The science, of course, is, I leave that, of course, myself to the brains of the world and the quantum physicists and all that kind of stuff. But we do know that, again, if you say, okay, the Big Bang happened, and so on and so forth, if you just think about the enormous odds that it would take for everything to come together the way that it exists now, and obviously has existed for some time now, um, you know, that's a really hard thing to just imagine just conveniently worked out at chance. I mean,
Right.
even
There's
for me, not even as a non-believer, that is extremely hard to wrap my head around, that it would just happen that way. I mean, you know, if somebody said, um, that, if we could see that, I realize, these, obviously these processes take a long, long, long time, longer than any of us are going to be around to see them happen with our own eyes. Um, but the fact is that, we call, Earth is the Goldilocks planet, right? We're not too
right.
hot, not too cold, and when you think about the universe in and of itself, again, just the fact that there's planets at all, things that, you had enough pieces of dirt stick together and rocks or whatever, and then, they start spinning around on themselves, and they're spinning around the sun, and there's several solar systems. I mean, it's really really mind boggling. And for me, that was one of the first things. It's like, that seems kind of hard to imagine it just happened all on
Right.
its own. you know um like I said,
So there's a different argument. There's a different argument within the field of probability. Once your probability gets to a certain infinitesimal place, it might be 0.000001 probable, but there's a certain point at which statisticians, is that right?
statisticians.
Statisticians
Thank you.
say, no, thank you. That is actually impossible.
Yeah.
It's actually beyond this point. It's actually impossible. And what we're talking about, it calculates far beyond what they would say is actually impossible as far as the possibility, the probability.
Well, I
There's
mean,
yeah,
that would be for it to happen in one case. I mean, we've got it repeated over and over and over and over. And the interesting thing is it's the same kind of repetition. Typically, you have a major, star, and you have you have planets, and planets have moons, and sometimes the moons have moons, and so on. And so it's not like it. Not only did it happen in our solar system, but it repeatedly happened in very similar styles. I know they're not all exact, obviously, but the concept in a general overview is the same over and over and over again.
Almost like there's a pattern, like from a designer's
Almost
mind.
like somebody was like, this is a pretty good template. I think I'll keep using that.
So you mentioned earlier something about, well, then where did God come from? If everything that begins, I said it wrong. I said it correctly, which is wrong. If everything has a beginning, then what is God's beginning, right? And that's really not the Kalam argument. What it says is everything which begins has a cause. Not everything has a cause.
Okay.
And so when we look at the physical realm, the universe, et cetera, all these things that have begun, where you get the heavy particles from, where you get the original whatever nothingness was there that was actually not quite nothing. Where did that first something come from? Well, those are the things that we are saying must have had a cause. But If it's something that had no beginning, it's not necessary for it to have a cause because it always existed.
Well, while we're here, if there's literally anybody watching, just throwing that out there, if there is one single soul watching, if you
Or
have
if
any
anybody
questions,
might watch in the future.
if you might watch or you're watching this in the future, feel free to post on the page or send a message. But we would like to know, what were you told? Maybe you were told by certain. I know people that their answer would not. They would never care to explain anything. Their answer would be like, "The Bible says so." It's like, good talk. And then you've got folks that are like, well, I don't believe that. I don't believe the Bible. And so you don't get really any, there's no real answer there. There's no discussion there. I don't, it doesn't matter to me personally what your opinion or thoughts are on it. I just like, we just want to know. I think it's interesting because that's how you find out where your hurdles are. And it may not even be a hurdle for you, like I said before, but it's always interesting because sometimes for me, this one was not believing that something had to make this all go into motion was a lot easier for me to grasp because I have tried just, winging it like on recipes. And I'm just going to tell you, I don't usually come up with a universe or anything close to it. Sometimes I just have to throw it in the trash. So not only did this happen, but it wasn't like a first attempt. This, it was like it happened and it was 100% successful.
Right.
It wasn't, think about it. In science or anything that we do, how many times we practice, right? We practice. We test out things. We test it. Will that work? Oh, sorry that you crash landed. I guess I didn't get that right. Well, try again, Anybody got another parachute? And so I think that's another thing that if you start thinking about it logically, is that this wasn't just a trial run. This was it, and it worked perfectly. And that is something that's very difficult to explain, regardless what your view is. And I mean, whether you try to come at it from a scientific angle or from a faith angle, either way, that is an amazing accomplishment. I mean, it's truly a miraculous thing.
Really points to a super intelligence for sure. Whatever
Right,
that
and it's
cause
not my
is,
super
it has to be
intelligence.
big. No, not
Right.
mine either, for sure.
Right, bigger than my intelligence.
We're struggling to just conceptualize this. So this kind of forms a little bit of our knowledge about that first cause. The first cause then would have to be not something which started, but something which has always been. Let's see here. He says that this concept rules out the idea of a God who has endured through an infinite time past. But that's not the classic idea of God. Time and space are creations of God that began at the Big Bang. If you go back beyond the beginning of time itself, there is simply eternity. So the idea of eternity here then would be no time. Time would also be something that would have begun at the beginning of the universe. So I got a pathway of science next.
Well, let's see.
Yeah. All right. So, general relativity does not allow for a static universe. As we look at Einstein's theory of relativity,
I like
we've
Einstein.
got it.
Great hint.
And actually, Einstein was disappointed. He really expected to find that his equation pointed to a static universe. And that would not be a cone. That would just be like a cylinder. Like whether it had a beginning or not, it would just be, it's always the same. It's not expanding whatsoever. What he found out and what we've proven is through our observations in space and so on, the universe, the galaxies, the cosmos really is expanding. These galaxies are speeding away from each other. So his theory of relativity makes it impossible for us to have a universe that is always the same. And that was Aristotle's view. Aristotle thought the universe is eternal. It has always been what it is now. And that's why you see these constant laws. Einstein blew that out of the water. You got anything on that?
Well,
What are your observations on Einstein's theory, Susie?
Well, when I was telling him what to write,
yes, yes.
I think that one of the things that we need to remember is, first of all, this guy really was a genius, and his ability to imagine these things. I'm trying to think of a way I want to phrase this, is that his ability to grasp this was probably better than any of us could imagine, right? So, I mean, I remember studying all that stuff in school and trying to understand it, but no, we just, we were just like, oh, that's great. Okay, what are we going to know to pass the test? And again, the theory of relativity, I mean, first of all, there's so many theories that have been out there that, of course, all apply to this subject. And it's amazing when you think about, no matter, I mean, nobody's out there going, oh, yeah, the theory of relativity, I'm just not really into that, because it's utilized literally in every, scientific platform that requires it, right? I think the other, the other thing about Einstein to remember is that the guy was very, very ahead of his time, really, for a lot of the stuff that he came up with. I mean, there is still stuff that people are to this day working on that Einstein was involved with, and they still can't really quite grasp it the way Einstein did. So I'm just saying, some respect for the guy there, right? But again, right, if those laws all created or were created, they would have existed from the beginning of time, whenever it began. And so they were there too. They just weren't discovered the way that Einstein discovered them until later, much later, obviously.
Exactly. Right. So, speaking of other theories, there's a theory of inflation. So here you have the Big Bang.
We're all experiencing that right now. Oh, that's not a theory.
Yeah, not that inflation, not that one. And so you would have a big expansion of the universe, and then it would taper off to a much different shape. Bill Craig's initial comment is, there's absolutely no evidence for inflation. There is not one scientific observation that would point to the idea of, this shape for the universe as opposed to the cone with the beginning. Let's see here.
I'm trying to see if I can pull this up on my phone so I can see some of the writing a little better, but
you can't ignore the writing. Just look at the big shape.
Just look at okay, cool. I'm looking.
Yeah, that's the important part.
Gotcha. Okay.
And the shape even is kind of, I guess it's not really, the shape is not misleading, but you'll notice the first, inch of that or so goes from 10 to the negative 32nd power seconds up to 1 year by this point. So that's a very short amount of time. Right. And then we go, from 1 year to 100 years here, and out to 13.82 billion years where they think we are today. So
gotcha.
The idea is this curve on the front is very different. It's that inflation. It's that it expanded very rapidly at the beginning, and then the expansion somehow
it stays pretty linear from there. It looks like it's continuous.
Close. Yeah. So again, there's no, what did I say a minute ago? No evidence for this at all. There are no observations. It's just like, well, this could have happened.
Yep.
With nothing to back it up. The other thing is, we still have the Big Bang. We still have a beginning point.
Yep.
And so whatever has a beginning must have a cause.
Right.
So
I also like how it looks
really
like
have
like those old tubes that went like old radio tubes, doesn't it?
yeah,
If you laid it
vacuum
outside.
tubes.
Yeah, it
Yeah.
looks like one of those. Not how ironic is that? A vacuum tube. Just saying.
Yeah. So you still have the singularity.
Yeah.
And that singularity is the name they use for the little bit of nothing that's right at the beginning point before it expanded so fast and so large.
Mhm. Right. Well, something has to set that in motion. I mean, that's just my opinion. I don't
Exactly.
know. I don't know what the trigger was, but something.
So we go to therefore the universe has a cause. Let's see here. This is obviously just the pure deduction. If something has a beginning and everything that has a beginning must have a cause, then therefore the universe, if it had a beginning, has a cause. Let's see here. It says, even atheist Kai Nelson said, suppose you suddenly hear a loud bang and you ask me, who made that bang? And I reply, nothing. It just happened. Would you buy that? No, of course
Well,
not.
I wouldn't.
Of course. and you shouldn't. Nobody should, right? It says this is an inescapable conclusion, and it's a stunning confirmation of the millennia-old Judeo-Christian doctrine of creation out of nothing. So, okay, so you have a cause for the universe, right? Well, that cause, is that cause personal? Is it a creator? Is it like the God of the Bible, an entity? Is it a non-entity? And before we get to our slide here, it says there are really just two different options here. You can have something that's a non-personal identity, like numbers. The problem is numbers don't create anything. Numbers don't take action on their own if they're inanimate. And the other non-personal cause will be something that's outside of the universe, something that's non-physical. If the universe is physical and it had a beginning, then whatever caused that beginning has to be non-physical, has to be outside of the physical realm, and therefore outside of the laws of nature as well. So the beginning of the universe cannot have a scientific explanation. The reason that it cannot have a scientific explanation is because before time began, before matter existed, before the singularity existed, you would not have had anything physical. It would have been nothing. There would have been nothing physical at all. Yes, you had a thought.
Well, I was going to say, I mean, but there's whatever there was that blew up, right?
Before that, what was there before that?
I don't know, Matt. I don't know. That's the whole point.
I know. Nobody knows. So before that, when there was no singularity, before the singularity, before that first bit that blew up, then it has to be that there could have been nothing physical. So the cause for the physical universe had to be non-physical. So for the explanation of where did the beginning come from, then we have to understand the types of explanations. So that's what we have here on our slide. Types of explanations: scientific and personal. If someone were to say, well, why is the kettle boiling? You can say, well, the kettle's boiling because the kinetic energy of the flame is conducted by the metal bottom of the kettle to the water, causing the water molecules to vibrate faster and faster until they're thrown off in the form of steam. Right? That's a great scientific explanation. A little brief, but it'll do for the purposes of our illustration. A personal explanation would be, somebody wanted to put the water on so they can make tea.
Both are true.
These are both true, adequate, accurate, legitimate explanations. They just explain the phenomenon in different ways from different angles, right?
Yeah.
So if we cannot have a scientific explanation for the beginning of the universe, then it must be a personal explanation. There had to have been a will that caused it. Let's see here what I have on this slideshow. I made all these great slides and forgot most of them. So,
Well, welcome to middle age, adulthood.
thanks.
Do what I can. Thank you.
Oh man, okay. Okay. So we already covered this. There cannot be a scientific explanation of the beginning of the universe because since it is the first state, there were no earlier laws or conditions or matter or energy or anything else that led up to it.
I would assume that its beginning is what created the laws and all the things that go along with it. I mean, they were created when it was created.
Exactly. So since the cause of the universe transcends time and space, it cannot be a physical reality. If it was physical, it would not have existed because it was before the beginning, right?
Right.
So a couple of wrinkles that people try to throw in here is like, well, what about the oscillating model? The oscillating model basically says that there are oscillations in the universe. So rather than a beginning point or a singularity, there was never any singularity, but rather there was always, you have the big crunch right here where it's thin, and then you have it expanding, and then it crunches down again, and then it expands again. So
what makes it crunch and expand?
That is a problem. And what you would do is you would write an equation that had constants in it that made it do that, right? But
somebody had to write the equation to make it do
that. and we still don't know if it actually represents the facts or not, right, even if you write the equation. Yeah. So let me see here. Recent tests run by 5 different laboratories in 1998 calculated a 95% certainty that the universe will not contract, but that it will expand forever.
That would make sense. Once something is set in motion, right? Once something is set in motion, it stays in motion.
Right.
Unless another opposite or opposing force. So.
Right. Scientist Susie. Yes.
I did remember something.
Yeah, I've been in the same boat, to be honest. I have to study really hard to remember all this stuff. But so you have this oscillating model, and it's just basically just unscientific. Let's see what else we have here. Let's see, one more problem. Even if physics allowed the universe to contract, scientific studies have shown that entropy would be conserved from one cycle to the next. This would have the effect of each expansion getting bigger and bigger. Now trace that backward in time, and what do you get? They get smaller and smaller, right, as you go back in history. And then you finally come to the smallest cycle and then to the beginning of the universe.
Right.
So just like the picture here, they are changed. The oscillations would have to change in size. Even if they were allowed to happen by the laws of physics, you would eventually still have a beginning. So we still haven't avoided something that had a beginning.
All roads lead to Rome,
They really do. As the more you read this stuff, it's like, oh, this either fits in the pattern of something that totally doesn't work, it's untenable, right, or it actually still has a beginning.
Right.
So here's the no boundary model by Stephen Hawking. So in this model, I know. In this model, you have no singularity. You have no point on the cone, basically, okay, right? And so if we could time travel, if we could go back inside this cone, you would eventually reach the cone. What do I want to say? You would eventually reach the apex of this curve, follow the curve, and then come out on the other side. You would, if you go back in time far enough, you would just follow the curve around, and then you would be going forward in time again. That's
gotcha.
That's the idea that we have with this model.
Like a
problem
boomerang.
is, right? So um, I love where Lee Strobel says, "Was Stephen Hawking wrong?" It's like, no way, this can't
Not
be. He
Stephen
couldn't have been
Hawking.
wrong. Yeah, he
He
is the
sounded
new
like a
Einstein.
computer. I know. Yeah. Well, the guy. I mean, the guy was amazing, and he could think of a lot of things. But uh, again, I'm going to say it. Like sometimes the scientists, their minds work in a completely different way, and I've read a lot of that stuff and still went, huh? So
Well, so what William Lane Craig says is he thinks Hawking made a philosophical error by thinking that having a beginning entails having a beginning point. Right? So with his equation, he has put in numbers that make this a cone. That's not the word I want. That make this a curve instead of a cone with a point.
yeah.
It still has a beginning point, though. There is still a point at which there was nothing before, and now there is something after. It
Right.
still has a beginning. All right, now I want to read you this. Craig added, now I've been taking Hawking's model at face value, but it's also important to note that he is only able to achieve this rounding off effect by substituting imaginary numbers for real numbers in his equations. So what are imaginary numbers? They are in multiples of the square root of -1. In this model, they have the effect of turning time into a dimension of space. So they kind of convert time into space, and therefore you don't have the point on the end of the cone, but you have this dome. That's the word I wanted, dome.
Dome, yeah.
Yeah. The problem is that when imaginary numbers are employed, they're just computational devices used to grease the equations and get the result the mathematician wants. That's fine, but when you want to get a real physical result, you have to convert the imaginary numbers into real ones. But Hawking refuses to convert them. He just keeps everything in the imaginary realm. So Lee asked Craig, okay, well, what happens if you convert the numbers into real ones? Craig says, presto, the singularity reappears. In other words, we get the point back on the cone.
Yeah.
He says, in fact, the singularity is really there the whole time. It's just hidden behind the device of the so-called imaginary time. Hawking concedes this in a subsequent book he co-authored with Roger Penrose. He said he doesn't pretend to be describing reality because he says he doesn't know what reality is. And really, when we look back far beyond history, that's what we all have to do. We have to take the data and ascribe what we think is the best explanation to it, right?
Yeah.
And so he says, I really don't know what was back there. I admit that. So what does it say here? He doesn't know what reality is. So Hawking himself realizes that this is not a realistic description of the universe or its origin. It's merely a mathematical way of modeling the beginning of the universe in such a manner that the singularity doesn't appear. This is really just a what-if scenario. And he still hasn't managed to get rid of the fact that the cosmos had a beginning point.
Well, that's because, first of all, when you have these kinds of theories, it's pretty wide open because probably I don't know that humanity will ever solve this question, right? To some kind of actuality. You said many times that he said this wasn't based in reality, and I can relate to that. A lot of my life has not been based in reality, but I think.
Should I ask you to explain that, or just take that on face value?
Yeah, there you go. I'm no scientist, but I do think it doesn't like. This one's harder. This one's even harder for me. I mean, it's hard enough to be like, okay, there's a point, and then it all happens. This one's even weirder because it implies that somehow there was a lot more something from somewhere, and then it did something. So either way, if you take away the curve part, all the same, the same thing still started expanding at some point, and we got what we got, just how we got it, everything works like it does. Again, no matter any of the theories you want to throw out there, the bottom line is that the arrangement of how everything ended is really what we can observe now, and that's pretty miraculous.
It is. It defies physical explanation.
Yeah.
It really does. So we still have the point. You kind of said that in your comments. We still kind of have that point. So again, that Kalam argument is whatever begins to exist has a cause. And what we've seen is they continually are trying to come up with models that don't have a beginning. They really want the universe to be eternal, because if they can get to that point, then they can escape this argument. But the science keeps pointing us back. Mathematics keeps pointing us back. There was a beginning at some point. The universe really did begin to exist. And so therefore the universe has a cause.
And I would love to know if we have any viewers, what they think. I mean, do you think that there was, regardless of your belief system, do you believe that there was a cause? Do you believe that there was a beginning point for the universe, or do you think that it is? I don't know. I really don't know what the other. I guess this is kind of dumb, but I don't guess I don't know what the other alternative would be. It had to start somewhere. It had to have. I mean, I don't really. When I was a kid, I kind of imagined like Earth kind of came to be, and then maybe all the other planets kind of got. Oh, they're like, oh, do you see what that guy did over there? We should do that. And because as a kid, I didn't really understand it. But when you get old enough to really understand what it all involves, you're like, that's pretty swanky,
Right.
And of course, without the sun in the middle, then it doesn't make any sense either. And then you got to have the positions of all the planets. And I personally believe, the planets all have to serve some purpose. I've heard that, I forget which one it is, one of the bigger ones, Neptune maybe. If it wasn't for it, then the inner planets would be hit more by meteorites and asteroids and things like that. So it's like I don't know how much of that is true, guys. I'm just throwing out things that that I probably read in the National Enquirer. But all there's like a bunch of 18-year-olds going, "What's that?" I wish there was a bunch of 18-year-olds. I wish there was any 18-year-olds that were watching. But I think that it's great. It would be the key point being, right, is again, it still started somewhere. And even if you want to say, okay, let's go with the eternal thing. All right, fine. You still got how many solar systems, and and they still all kind of mimic the same kind of setup. Not all of them have these orbits and stuff, but the typical setup for a solar system is that they all have a sun that they exist and rotate, or I'm sorry, and revolve around. I get it. Maybe not every one of those are exactly that case, but the concept is there. And it just seems odd that would have been the result of just some random whatever expansion, and that it all worked out the way that it did. It just seems highly unusual, Watson.
I want to kind of look at what William Craig says about this cause. We've touched on it some already. It says, Lee asks him, how much can you deduce about this cause? He says there are several qualities we can identify. A cause of space and time must be uncaused, beginningless, timeless, and spaceless. Because it started all of those things, it must be greater than them and therefore outside of them, right? So it has to be whatever that cause is, it has to not include those things. And he goes on, immaterial, which basically means not physical, right? Having no matter. And he says a personal being, endowed with freedom of will and enormous power. So if there was no freedom of will, there would have been no decision. Yes, I want to cause the universe. So this cause had to have freedom of will as well. And obviously, with everything that we see, has to have, we've put a space station up in Earth, in the orbit around Earth, and we think we are big stuff.
Oh yeah.
You just compare the mass of that space station to our moon.
Right.
It pales in comparison.
Right.
Certainly pales in comparison with Saturn and the
And
other
look what all
giants
it
that are
took. And look what all it took, and the knowledge that it took in the
right.
years that it took to accomplish that.
Yeah. So, this Kalam argument and its implications are really huge. We even get to the point where we say, okay, well, it had to be a non-physical cause. It had to be a cause with freedom of will. That has to be a personal cause. It cannot just be some kind of event. It has to be a personal cause with a free will. It's pretty cool. So
Well, I think to end up the way that it did, there obviously, I feel like there had to be a plan of some kind behind that.
Exactly.
Only because of how the end result was. I don't know. I mean, I suppose, I know a lot of people are like, I think I'm just going to try this and see what happens. They usually end up missing an arm later. But most of the time when you try things just to see what will happen, you don't get what you have with the Earth and the planets, the universe, and all the laws of physics. So they're pretty much on the money. I think the more time goes on and the more science can discover, of course, this may help us understand it better. But I don't know that we'll ever have, of course, 100% answer. But if you're using, an open mind, you can say that it's pretty unlikely that we would have ended up with what we have just because something happened however many billions or whatever years ago, and it all perfectly aligned to what we've got now. I mean, you got just I would say just enough dirt, but there's a lot of places that could really use some more dirt. There's some places that could use some more water, but you know what I'm saying. I mean, it's just really interesting that you've got salt water, you've got fresh water, you've got mountains, you've got valleys, you've got trees, you've got animals, and none of those things would exist unless all of the things from the very beginning, when that set out, came together like they did.
Yeah. A lot of times, and I alluded to this in one of our previous episodes, we hear this thing like, well, you can never prove what the beginning was. Scientifically, no, because that's based in this physical universe. That's
right.
Based in physical data and observations. And the beginning obviously was before anything physical existed. So now we can use another type of reasoning, that personal reasoning. And that's kind of what we're getting to with the Kalam argument. Mm-hmm. I want to end with some teasers. The next show is one of Susie's favorites, and she keeps on referring to it in different arguments in this realm. And that is the balance of the universe and living in the safe zone. So we're going to talk about the galactic habitable zone, the habitability of galaxies of different shapes, the supermind, and the fact that the cosmos is balanced on a razor's edge.
Yeah, that was a really good chapter in that book. So we are, of course, referring to a book called The Case for a Creator. It's by Lee Strobel, wonderful author, very cool perspective from a gentleman who is an atheist, but still came to see that there was some very very interesting results. So I think that is something that's. I think that was, that is a big deal to me. I mean, the fact that we are where we're at and everything is like it is really interesting to me. It really is.
We want to say thanks for watching. Join us